Alright, automatic control principles and practices. Chapter 12, control system. It's one of the consider the control of the temperature, control of the isolate with the phenomenon, activity with the closed loop, with the swim of the measuring process, and inevitably be aware of the numerous details, influence of the action, hence of the selection of the controls of the total of the industrial production arrangement of the difference of the one between the specified of the control and component of the engineer control system, and illustrate with the control system, the convenient use of the system of the symbols of the identification, allow with the representation form of the flow plan, of the sound system has been developed the entrance society and instrument societies of America contain the recommended practices. Show the instrument processing line, hydraulic lines, instrument air lines, instrument electrical leads, instrumental capillary tubes, locally mounted. All lines find to be relation to the process of piping. You have your basic symbol, locally mounted basic symbol, the instrument, a single surface function, locally mounted board mounted basic symbol, the combination instrument, the device with two surface functions, locally mounted board mounted basic symbol for the transmitter, locally mounted board mounted basic symbol, the spring output of the diaphragm. Basic symbol, electrically actuated valve, solenoid, or motor. Basic symbol, piston, actuated valve, hydraulic or pneumatic. Through-way body for any valve. The basic symbol for a safety relay valve. And then basic symbol for a self-actuated integral regulating valve. Basic symbol, the manual operated control valve. Basic symbol for showing pneumatic transmission instrument, electrical transmission, same except the type of the connection. And then basic symbol showing pneumatic connection instrument with a spring opposed diaphragm valve. Basic instrument symbols are shown in figure 12.1 in order to identify the control component of the instrument over the flow plan file when the letters of the combination are used. Alright, letter A is second letter, first letter, second letter is alarm, third letter is alarm. C, the conductivity, first letter, second letter, type of the reading, other function with control, and third control. D, density. E, element. P, element, second letter, type of the reading of the other function. E, element primary. F, the first letter, flow. G, second letter, glass, no measurement. H, hand, actuated. I, indicating L, level, first. M, first, moisture. P, first, pressure. R, second, recorder, recording. S, speed and safety, and speed first, safety second, temperature 1, viscosity 1, weight 1, W, weight, second, well, and then, alright, the following may be used optional with the first level of the other profitable variables. A may be used to overcover all the types of the analyzing instruments for reading, recognize the health advising chemicals, some of the carbon dioxide, the oxygen, etc. may use the specific analysis of the instrument with a self-defining symbol. The pH may be used the hydrogen ion concentration. Furthermore, with the measurement of the insert with the lowercase r after after F to designate with the flow rate, likewise with the lowercase D with the maybe the insert with the F with the T and P with the designate with the temperature difference and pressure difference. And flow contains several units with the equal letter identification become the necessary for the supplement, the general identification, the numerical, the system, and the specific identity with the identification TRC1 with the refers to the temperature recording control with the item number 1. Figure 12, they comply with the system with a typical instrument with the fractional column with the feedback with the fraction column and is maintained with the constant rate, at which is still a set point with the flow recording controller with a set point with the automatically adjusted with the level of the recording controller. Level controller maintained with the non-fixed with the average level of the arrangement combined with the average and cascaded control with the described further below it propose with the reduced fluctuation feed flow rate as much as possible. So here we have a typical instrumentation function, fractional column, feed tank, and then you have the different lines. Your feed going into fraction column, heating mediums, and your flux accumulator to product, fraction column, bottom product. The situation somewhat similar to the control flow rate with the heating medium with the flow rate has to keep the constant even over the upstream with the downstream pressure when they change the on the over the hand temperature fraction heating column must keep the constant with the hence for the purpose of the cascade with the control of the cave with the chain with the set point with the flow recording controller by means of temperature recording control with the remaining controlling loops in this case with a single loop with the control with no further description as so much. Averaging control and feedback with the figure 12.2 with a quite power permissible to a level 2 with a fluctuate between a certain level of the greatest importance for the flow with the fractioning with the column does not change with abruptly with the control. This is for the kind of purpose of permitting the variation from the control of the variable to be larger for the required of the system dynamics is called the averaging controlling system. Suppose the maximum permissible the rate of change is 3 3/4 with the gallons per minute with a gallon per minute within over a minute with the control valve with a linear characteristic of the character capacity with 37.5 gallons per minute with the prevailing pressure with the minimum time with the full stroke with it should be 10 minutes with it could be effectively hydraulic with the control of the select with the corresponding with the flow rate with the actuating medium piston air with the pneumatic control with the conditions such with the time and the final control element and not practical approach if the problem is different from the discussed further below but the form of the speed of the final control element is adjusted as necessary to a certain the rate of the flow in the tank chamber that always conserve the below the weight below 3.7 gallons per minute. If this exceeds the rate with the only intermittent time during the flow rate and with the tank can be exceeded the maximum rate with the chain with it depends on the capacity of the tank rate of flow of the tolerance between the maximum and minimum level of heat tank with the tolerance generally high. Considerable amounts can be absorbed. Furthermore, limited control to provide with the tank safety measure in this case leaves limited to see with the boiler drums or not. More critical to respectively in this case in their case with the flow and the drum with the beat chain with the gradually to avoid shot with the level is allowed with the fluctuate from plus or minus 2 inches for the usually considered the limit. Furthermore, flow rates with zero larger than the with the feed drum of the load may be changed rapidly with the chain carefully studied show the given the possibility of the load might change with a faster than feed water flow with the drain of the boiler drum beyond the minimum level before with the control valve of the feed line can follow it would stay with the pneumatic control of the simple speed adjustment of the final control element that cannot be adjusted hence well with the hydraulic control of the proportional speed floating control that can be used with the proportional position with the proportional plus reset action which use the final control element of the pneumatic actuate the point and then with the select with the widest possible the proportional band with a method of determining the proportional band is described with the following paragraphs for a tank of the 8 feet of diameter area with the 7,200 square inches of the permissible level of variation plus or minus 20 inches. Volume contained between the minimum and maximum level of approximately 1,250 gallons. Figure of 12.3 illustrates the case where maximum flow of 250 gallons per minute in the tank. They show the flow in with a maximum minimum level of 40 inches. 96 inches is the tank, and the LC is your. And then to a valve. It's necessary for the valve to reach the position maximum level at 250 gallons per minute that are allowed to flow out of the tank. The minimum flow of the 50 gallons per minute of the tank may exist. Hence, for the minimum level, the valve should be sufficiently open to allow for the outflow of 50 gallons per minute. The valve is rated with a maximum capacity of 300 gallons per minute. This means the control output signal should be at least 5 psi, but at the minimum level, 13 psi with the maximum level. Since the levels are at 40 inches apart, proportional band with the controller is 60 inches of the chain with the controlled level. The flow rate of the chain with the 5 gallons per minute with every inch of the chain with the tank level. The proportional band is given by the P. The proportional band is with an inch of the control tank level is equal to the V. The maximum flow of the capacity with the valve in gallons per minute over the Q of the proportional band equal to over Q of the maximum southern chain with the flow in the tank of the gallons per minute is the times tolerance between the maximum and the minimum level of the inches and valve capacity depends on the level in the tank. The maximum level is most critical, the hardly convincible. The maximum level coincide with the maximum flow chain with the condition may be assumed that in order to be safe side, they assume that the valve of the linear character of the valve could be employed in this system. The valve character with the compare charge for the fast chain with the rate with a given displacement should be the stop with the greatest and fastest chain of the flow in the tank would be with the shove and the increase of 200 gallons per minute from 50 to 250 gallons per minute. Since the volume between the maximum and minimum level of 1,250 gallons per minute, the level rises for the 200 gallon minute times 40 inches of 12 over 1,250 gallons if it is equal to 6.4 inches of the minute. Consequently, the volume would be initially opened with the corresponding rate of 5 gallons per minute in inches and rise with the level within 32 gallons a minute in the minute. Procedure can be extrapolated in this equation where Q, the minute and the rate of change of the flow obtained with the valve action of the gallons per minute is equal to maximum southern change of the flow in the tank of the gallons per minute times the L and V times E with the tank with the capacity made between the maximum and the minimum level in gallon. The other factors correspond with the equation of 12.1 of obviously either case with the other consistent units might be either. The equation can be either various ways. For example, the fastest permissible rate of the chain of the flow is given in 16 gallons per minute with all the other conditions same as before. The Q equals minutes. Rate of change of flow of the chain with the valve action and with the gallons per minute with the 16 and an inserted valve with the equation. The values of the equation 12.2 thus over the proportional band, the result of the proportional band of the 120 inches. Since the equation contained with the tank capacity between the maximum and the minimum level that permits the selection of the correct tank with the given set with the condition, it has been assumed with the proceeding with the Q, the max. Q, your rate of your Q, the proportional band with the maximum sudden change of flow in the tank, the equivalent with the change with the minimum with the maximum flow in the tank. Actual sudden change with the may never happen. Doesn't happen. Permissible or limited change with the switch of the opening with the dumb valve with the tank with the similar with the precaution the measure for the under of the condition valve of the proportional band made you with the corresponding smaller. Certain modifications involved with the assumption contained within the foregoing. For example, the flow in the tank may reach at its maximum only with the intermittent in the case of the band with equation within sublimated with the factor m, which cover the difference between the maximum and the minimum flow that can be expected. Hence, that your proportional band becomes necessary now considered larger than its insertion equation rate. Result of the smaller tank with the slope of the maximum rate to change the flow. It should be noted that factor q is in the equation remains unaltered and assumed with the fluctuation through the maximum range band curve of the intermittent. If it's not the case, the further correction are possible. When using an equation with a 12-1 with a proportional position control, it is to be the case of the equation. However, the require the proportional plus a reset control of the region with the offset of the degree of the proportion absorption of the potential of the tank. The U with the proportional position control without the reset of the means with the considerable offset of the view with the large proportional beam with the used an average control of the control point and therefore drift the control considerably from the set point of the near one level to the limit to when the other sudden load of change the curve of the as long as the proportional band is then adjusted according to the equation level. The limits can be hardly be exceeded with no advantage of the reset action can be expected. If sensitivity of the controller function is decreased in accordance with the equation of the 12-3 with the reset action required the distributor, the control point always drive the back for the set point with efficient absorption capacity of the tank with is available for the time of the loaded chain with the advisable limited switch for the provide in such arrangements to the provide dumping a similar precaution measure for the case load changes or occasional large or more persistent expected. Cascade control. The cascade control has two purchases. One control for the two or more of the different kind of the load chain, but the other is to improve the dynamics of the system and effect of the reading of the dead time of the system. Figure 12.4 shows the level of the control system feedback tank with a similar to that in Figure 12.2, but again with the main purpose to avoid the rapid chain of the feed flow of the rapid and liquid level of control is used. However, the protect for the only against the sudden chain of the flow in the feed tank, in this case the another variable because the important, namely upstream and the downstream pressure. Changes of flow must be keeping the confident no matter what the pressure conditions are. It must be changed with the level. In other words, to kind of the load change if there may be control of the pressure for the and the tank level of the solution. Illustrated with both the flow diagram, block diagram 12.4 of the second control system connected into the level of control loop, level of control and cascades into the flow. Control of the method is basically simple. Also, the required is flow. You have the feed tank. You have the your flow diagram. Set point, level controller, process level of process, flow controller, controller. Alright, controller loop with the reference input with the obtained with the level of control with the flow with the captive with the automatically constant with the given and set point chain with the upstream with the downstream with the cannot affect if the level of the chain with the however the reference input with the signal change the offset with the reach of the set point with the flow rate with the control with the flow controller. It's interesting to observe the block diagram the equivalent level of breaking the process into the two parts of the flow with the process with the level of the process is happening point between the two ports to obtain additional feedback loop with the control of the loop. Figure 12.5 the represent the polymers with the cascade and the temperature with the control system. The particular system is designed with the Bristol cove with the polymer with the kettle heat with the hot water with the capacity with the jacket around with the kettle with the temperature inside of the kettle must be kept calm with the temperature with the needs not only due to the load but the condition of the kettle but also change with the steam pressure with the quality of the as well with the change of the cold water pressure and the temperature of the arrangement show within one temperature of the recording with the control of the TRC temperature recording of number 1 to ensure the temperature of the product inside the pressurized kettle with the second temperature recording with the temperature of the TRC. 2 for the measure of the temperature with the hot water check with the controller is and to keep the jack of the temperature counts with the compass with the position with the 3 control valves as long with the valve to drain when the cold water lines are closed with the hot water circulates through the bypass with each valve. They're always identical with the position when they are open and more cold water is emitted reducing the temperature in the jacket. So it shows the automatic polymer control system, the hot water jacket, the aggregator, the condensate, the heat water, the TRC 1 and 2, your drain and your steam and your cold water. Or the drain in the cold water valve to fully open the single pressure with the 3 psi with control of the temperature recording controller. 2 signal increase the close gradually. It's 9 psi. The close completely remain closed with the further increase of the pressure. On the other hand, the steam valve remains closed with the 9 psi begin to open and the pressure rises further, being fully open at 12 psi with 15 psi with now, and thus at 9 psi all 3 valves are closed with the water circuit but no heat with the cold water is added. If the temperature drops below this point, steam valve becomes open and the temperature rises with the cold water is added. Temperature recording controller 1 in this case the proportional plus rate with the control of no reset action add avoid with the overshooting on the startup. This is the frequently start with the batch profit the trailer and terrain. Temperature recorder 2 has proportional position action only with the process because if the 2 sharply separated with the capacities, one with the capacity with the jacket, the other is inside of the kettle, both with the capacity with the separated with the inner kettle wall. It has been pointed out the previously respond with the curve of the multiple capacity profit can be split in the time of the constant equivalent dead time of the disadvantage of the dead time of the actual equivalent has been discussed after the length of the polymers control with the other conservation cascade of the system actually eliminated with the handicap by splitting the capacity Inviting intermediate feedback signal with the trigger 12.6 if it is corresponding block diagram. The arrangement of the degree diagram does not differ for the figure of 12.4. B for the feedback between the two capacitance. However, the illustrative additional character for the feedback, which is improvement of dynamic characters with it without it. Set point, it has your control set point, control temperature recovery to controller 2, temperature recorder 2, checking capacity number 1, capacity number 2, and that switch direction of the temperature change with the delay for the heat flow with the compromise of the two capacity of the resistance, connecting them with the introduction of second temperature control with the jacket signal to the process temperature before it actually takes place. Of the cascade of the controller requires 2 or more control with each of the which for the contained complete measuring system, a complete control unit. One of the controls a master control of the position set with the point with the one more with the control secondary pneumatic ion set with the outside with the control of the block diagram figure 12.6 for the control temperature recorder 1, master control with another temperature recorder 2 is the secondary control while the master control of the eventually 1 or 2 of the 3 term with the control of the second controller require the modification single with the master with the secondary control of the converters certain range of the simple cascade with the control of the single range of the equivalent extreme of the set point index secondary controller move with the one extreme of the both over the other result of the limitation adjusting with the control of the active the action of both control of the manual adjustment therefore frequently provide the change of the rate agent of the zero motion the set point into the secondary controller. Your secondary controller is generally designed but they also permit reversibility with the action of the two interrelated with the control variable with the cascade control system master primary variable the secondary variable. If the increased magnitude of the master variable raises the set point with the secondary variable with the action is called with the direct. If it is lower with the set point it is a reverse action. Figure 12 7 illustrates the operation of the Taylor pneumatic set with the control of the set adjustment pneumatically with the input of the air signal and shows signal with the master instrument, the pneumatic adjustment with the mechanism indicate with the solid line difference for the control mechanism. Show the process 20 pounds of air supply, quarter-inch OD computer off the outer diameter copper tube with the master instruments, and then they're labeled there, and you have the 20 pound supply, air supply. Alright, with the pneumatic adjustment mechanisms, the indicate for the solid line with the different with the control mechanism, the indicate for the impair air signal, entry for the pneumatic adjustment with the unit with line 1 at 6 with the set point will be ready with the means for the direct shaft with the reverse action required with line 1 attached to 5. Direct section shown with the increase with the single pin with the left and the restore with the right parallelogram 12 with the transit move with the 2 with the arm 15 with your pivot on 13 move with the upward result with the upward motion on pivot and 17 transmit with the real link 18 with the bell crank 2 with the pivots with the 25 link 23 with the attached with the flow gear 19 with the which sets point index attached. Draw down with this move with the set point index to the left. The amount of the travel set point with the index per PSI change with the input with the air signal to regulate with the span adjustment now with the travel increase with the knob with the turn with the higher dial reading the dial is calibrated with the index into the index travel to PSI per chain with the input air signal with the cover the range of the 0 to 4 tenths of the inch per PSI. Span adjustment required set point index travel per unit with the change the input with the air signal to determine the the equation A over B equals C with it which is A is linear distance for the index travel inch is measured for the radius the center with the chart and B the total change with the input with the air signal and then C with the setting of the span adjustment with the knob and inches PSI for the example the set point index with the 3 inch for the further variation with the input signal with 3 to 15 PSI with the dial set for 3 over 15 divided by 3 divided by 15 minus 3 equal to a quarter inch for the per PSI with the span adjustment 0 per PSI reduced with the pneumatic set with the control with the conventional pneumatic control with no longer respond with the chain with the input air signal with the control with the set point with which of the determinant the adjustment with the knob 21 various methods of either determining upper and lower limit the 2 with the set input with the index for the secondary control move with the other one method is to take a spin adjustment 0 with the set point index with the position condition defines index position and any other of the span adjustment with the input air signal with an 9 psi with the midpoint with the 315 psi another method of 0 adjustment which set with the lower point with the range which of the set point index move in either case with the range of set point index motion is shifted either upscale with the downscale adjustable control limited stops with it frequently built into for the secondary control the secondary variable has to be maintained with a certain limited stop can be positioned with the control point does not exceed these limits. Alright, ratio control. The purpose of the ratio control names the relative magnitude between two variables which we concern with above the absolute magnitude of the simplest form of the open loop of the arrangement figure 1280 for the flow of the through line A, the measured supply with the actuating civil the flow control of the valve with line B, the position for the flow controller arrangement contains the uncertainties of the open loop while the pressure in line B is assumed with the B constant for the control loop the linear is obviously the idealized condition which cannot be obtained. However, some of the cases that may be sufficiently approached to be acceptable the only approximate ratio that required with the unsubstantiated condition for example the 12A provides a simpler and inexpensive arrangement. Alright, so you have your FC with the line linear line 1 and B, the regulator, line A, flow control, line B. So F is your flow controller. That's your controller element. This is the circles, I guess. Consider improving the same with a close movement method illustrated in the figure 12.9 flow line A called the primary flow with the non-compliant compared in flow line B, but the secondary flow with the controller maintained with the secondary flow rate, which can only be varied by primary flow changes. Line A the flow charger to the pressure relief valve, the pressure valve. Line B line A ratios setter with the controller through the flow control with line B. Measurement signal of the primary flow of the R goes into the ratio mechanism multiplied with the input of the R by the factor X with the given by the manual readjustment ratio, etc. The assumption of the point received the the reference input signal is to KR combined with the measurement of the input measurement signal B with the secondary flow with the difference between KR and P. Actually, signal of the control output signal from the core control regulates the secondary flow with making the difference between the KR and B to equal 0. Hence, KR minus B is equal to 0 or RB over the is equal to K, which means the ratio between the R and B between primary and secondary flow is equal to K. In other words, the control system maintains the ratio was given an adjustment with the ratio setter. Figure 12.10 shows the hydraulic ratio control of the differential pressure of the measure off the orifice wave through the primary flow path with the differential pressure of the transmitter of the diaphragm of the force arm of the diaphragm is applied with the counter lever. 2 over the ratio slider. 3 with the jet pipe. And show the primary element of the primary flow. Your final element, the jet pipe with the primary and element secondary flow. And then show the oil, piston, hydraulic control ratio of the secondary flow with a similar mean with the resulting force of the diaphragm. 4 with the directly transmitting the jet pipe with the position of the jet pipe to function for the 2 force of the 2 with the primary secondary flow respect with the force of bounces around with the 2 point. So the pivot point with the ratio slide within the equation. The obtained with the lever dimensions of the D and wires shown in figure 2.12.10. The use of F1, the force of the primary flow, is equal to the dimension D over D minus Y, and equal to the force from secondary flow, since this shows as force 1 over force 2 with equal to D minus Y plus over D plus Y. Illustrate the ratio of the F over 1 can be changed with the dimension of the D is fixed with the dimension Y is adjusted by the means of the ratio setter. Either 2 flows change the base and balance between the 2 forces distributed with the jet pipe to deflect with the root, providing a controller. Output signal of the final control arm with the resulting adjustment of the secondary flow reestablish ratio balance with the final flow ratios automatically adjusted in response to a third process variable. This case is illustrated in figure 12.11, where the feed flow and reflux flow with the distillation column of the maintained with a constant ratio of the temperature of the rise of the ratio feed with the reflux with the supplies to increase the show. The temperature is measured and the output signal with the temperature controller utilized with the ratio between the feed and the reflux action of the air is 2 control variables. The temperature and the ratio of the air also for the 2 complete control of the heads of the cascade system have with the temperature controller cascades and it's into the ratio system block diagram shown with the 1 process for the variable the feed is not part of the closed loop with the clearly expressed with the cascade system is also involved. 2 and 3 element control equation in the first version is KR minus B is equal to 0. Show the ratio of the controller be considered as a projecting control system just as well as ratio system. In fact, the difference is the viewpoint rather than in the action changing the ratio to be considered the alternating with a set point with the subtracting from the some other value. With the illustrative example is found with the maintaining level of the boiler drum, assuming the demand with the increase of the monetary swelling with the water in the drum curve of the time similar with the demands drop the monetary shrink with it takes place with the level of control of these phenomena produce the undesirable upset of the balance of feed water flow. In 2 element system shown in the figure 12.12 the output signal and flow controller is used to adjust the set point of the level recorder. So you have the go flow controller, and then you have your load resistant load recorder, boiler drum, and steam and feed water. Level controller regulates the valve position of the feed water line as well as the steam load flow, and the concept of the system respond with the only change of the level of the system. The steam flow change of the set point of the lever control that is automatically adjusted to provide for the corresponding change of the feed water flow. Resultantly, in this case, the increased steam flow with the level of control of the will call for the less feed water flow with the cover of the swelling, while with the steam the flow control valve call for the increase of the feed water flow. Through signal to cancel out the feed water flow, but remains constant until the monetary of the swelling subside. At this point, with the increase of the demand of the steam flow with the result of the increase of the water flow by the method of the load chain with the result of the minimum of the upset with the boiler steaming condition. When a permanent change is a set point with the hence of the level, it cannot be tolerated with the feedback signal with the final control element that may balance the flow signal as well with the level signal with the arrangement of the sort. Illustrating figure 12 to 13, the chain with the steam flow chain with the differential pressure of the off the ore for the differential pressure that is applied with the cross of the diaphragm acts as a force on the beam, the which position with the four-way valve, the result of the displacement of the actuating piston and the operator for the control valve with the primary feedback with the level that operates similar with the fashion with, for example, the level, the rise of the flow motion relaxes with the spring that connected into the lever, the result of the clockwise motion, and show the supply of water and steam, two-element control system feedback. Lever of the four-way valve that emits oil with the top of the piston, intending for the clove of the valve. The downward motion feeds back to the level of the beam to the spring with the resort and the balance of the new position of the control valve. In case increased steam demand monetary swelling of the level to drive the move of the lever clockwise, while the increased pressure differential opens with the opposed to this motion. The result is that the control valve does not move until the swelling subsides. Normally, a manual set point adjustment is added in however, which is not shown in this diagram. Figure 12-14 illustrates both methods of the two-element control. In either case, the flow signal is given the reference input with the level of the controller system valve position feedback within the second give the however the subtracts from the flow with the reference input with the under balanced conditions of the input into the second assumption with the point where it becomes zero as far as the flow signal is concerned. The actuating signal is the level of the controller is then merely the difference between the manual set point and the primary feedback. The three-element feed water control system combines the typical with the cascade level of the control system with the steam flow correction as illustrated in figure 12-15 with a particular suitable where the load disturbance for the feed water supply side to be expected. The three-element system permits further use of floating control since the boiler drum has no self-regulation. Floating control cannot be used unless three-element system is usually later converts the arrangements into show the control system flow reference endpoint into the control and then the lever control. The control system and the lever controller and the process level back to the A's without valve position feedback and then flow reference input and then set point level control process level. That's your with the valve position and feedback. B 12-14 schematic drawings of two-element systems, and then you have feed control, limited load control, feed control valves. Three-element control system, flow control system, self-regulation into which the output over the level of control is cascaded. Alright, totalizing. Oil refining steel mills accept the byproduct of fuel frequently burnt with it either separately or with a combination with the coal and oil with the natural gas in order to obtain the economic source of the thermal energy for the steam boil with the multiply the fuel combustion present with the interesting control problem of one of this is the total BTU supply with the fuel must be maintained generally. Other byproduct of the use of the base fuel with the byproduct of the supply with is rarely constant with one over the sometimes to do with the makeup of the fuel, but therefore with the required in order to maintain with the constant BTU supply with the furnace. Another problem is the ratio of the air and proportion to fuel. Frequently, some of the indirect methods are used to maintain a constant ratio between the steam and the airflow with the steam boiler fuel gas the animals may be employed in order to proportion the air with the oxygen content of the flue gas. Most directed method, however, is the direct ratio of the air to flow with either separately with each of the fuel with the sum of the total of the fuels as compared with the gas analysis. The method to provide with the faster control of the stream of the correction that can be made with the moment of the fuel flow rate change with the end and not after the result of the train with the become with the measurable in flue gases. Disadvantage however the proportional air within the fuel flow is resulting the volumetric ratio of the correct ratio between the air and fuel is based on weight either with the air with the gaseous fail or the chain with the pressure for the temperature for the ratio will lose accuracy unless provisions are made which correct these changes. The figure 12-16 illustrates the principle of the haze fuel totalizing the control system with the total BTU input with the control variable with the system with the designated magnitude of the total BTU is adjusted by means of the BTU controller pentameter with either manually or automatically by steam pressure for the control of the temperature control of the arrangement of the shown either in fuel 1 or fuel 2 by the base fuel with the remaining fuel with the makeup of the fuel with the flow rate with the base fuel with the main variable with the yet totally BTU input with the maintain with the desired value by adjustment automatic adjustment with the makeup of the fuel with which one over the two fuels is to be base fuel, with which makeup of the fuel can be determined by manual selector switch flow meters to measure the flow rates of the two fuel with the meters of them provide with the mechanism for square root extraction. So the output of the proportional of the flow rate of the pedometer of each of the flow meter of the position of the proportion to the rate of the respective flow. Output of the two pedometers should average by either the center tap of the auto transformer with the average voltage for the applied with the coil to the relay. The relay contact with the operating valve actuated with the adjusting control valve to make up the fuel with the relay closed with the one contact with the actuator open to the valve with the valve. When it closes with the other contact with the valve closes, the valve maintains its position when none of the contacts is closed. While the BTU control pedometer is given the position representing of the finite BTU input demand, base fuel being burned is in quantity. Shows pedometer fuel number 1, 115 volt power supply auto transformer relay. Pedometer fuel number 2, input ratio adjustment, BTU control, pedometer fuel selector switches. To control valve actuator fuel number 1, to control valve actuator fuel number 2. Less sufficient to meet the demand with the electrical relay closed with the corresponding with the contact opens the valve with the base fuel of the unit until the flow is measured with the flow rate meter reach for the desired level with the relay contact with again opened with the figure 12-17 show the principle of the ASCII and multiple fuel control system. In this shift the two fuels are burnt in the furnace. Air is supplied with the match of fuel with the arrangement is as follows. Small balloon with the compressor air supply source to provide with the pilot airflow with the root with the two lines each with the about with the 1 inch in the diameter ratio control with the measure of the primary diaphragm with the differential pressure across over display from the fuel line 1 and by the means of the hydraulic flow through A with the jet pipe with the controller position with the actuating piston with the control of the valve and C pilot airflow with arrangement and A orifice on plate C with the branch provided with the differential pressure with an input on the secondary diaphragm with the control A. The controller A with the a rate of the pilot air valve is also obtained with NC with the which of the directly proportional to the rate of the flow in fuel 1. Ratio controller B with like manner with the measure of the flow of the fuel from means of the orifice plate within the fuel line 2 with the deterrents provided with the means of the so we have fuel 1 A pilot airflow C and D, B and fuel 2. With a air Alaskan totalizer air ratio control system. Controlling an air pilot valve with a portion of the fuel with us, it's an air requirement. Therefore, controllers A and B with regulate the rate of the airflow with the C and the D and such a way with the airflow each of the line with this proportional to the flow of each of the fuels with each of the airflow with the number of together the total of the flow of the measure mean the orifice E with the provided the preliminary signal for the ratio of the controller F with the combustion air with the regulated with the last controller, which means that this fixed proportion with the common pilot airflow with which for the representative of the sum of the fuels 1 and 2 with the ratio slide with the A and B it may be set with the different air ratios. Corresponding with the requirements of each of the fuel, but it can also be automatically set with the function of the temperature for the pressure for the gaseous fuels. Thus, correct the chain with the intensity of the same hole for the true of the combustion air ratio controllers. Time schedule control. With the time schedule of the controller regulated the batch profit according to some of the predetermined time schedule of the various methods that are described here with an illustrated in figure 12.18 with these are available in line of the time schedule controllers made by with the Foxborough company with the automatic shutdown controller served in cycle with the push button with the depressed the opens the valve leaves it open until it is controlled. Ensure the shutdown, the start button, push button, open valve, button, open valve with the shutdown control, closed valve with the automatic shutdown controller. Alright, set point, elapsed time, the elapsed time controller, and set point, elapsed time controller with the deflection, deferred action. Then show the cam set controller, 360 degree rotation of the cam, top temperature controller point, base control point, cylinder log controller. Or figure 12.18, action of the various step of the Foxborough time schedule. Control the variable to reach for the predetermined value of the shutdown point of the valve. The term then shuts down automatically. The elapsed time control of the servo, the pre-selected time period of the width, and this it brings the control variable to its set point with the end control of the point. At the end of the period, the valve is automatically closed with the elapsed time control of the deferred action. Difference in that with the elapsed time of the counting for the time of the variable control variable to reach the set point. Cam set the control of the regulator of the schedule according to the contour of the rotating cam while the full 360 degree cycle of the rotating cam is not required. The cam to return with the starting point with the bias command with the adjustment of the cycle log with the control of the preheat of the batch with maybe any selected base of the temperature. If it hold the control variable with the temperature of the preset of the period of the time, that's if the time of the temperature of the valve to arrive at the pre-selected rate at the top of the set point with the hold the batch, the top set point with a certain period of time and after with the automatically shut down with the process of the two steps with maybe the average indicate with the dash line figure 12.18. They consist of one predetermined prolongation of the time with which valve stays open with the pressing a push button, and two with the provision of the control rate of the cooling. There are only a few large number of variations which are even in the control system where control process becomes of the time and the function. Alright, Chapter 13, Industrial Applications.